Ohm's law. This is a very famous law that allows us to predict what happens to the current in a circuit if we increase the potential difference. It introduces a new quantity called resistance. Resistance is a measure of how difficult the current finds it to go through a component. It is an important part of the course. There are 2 required practicals in it, for example. This circuit diagram shows a power pack at the top. It can supply a potential difference of between 0 and 9 volts DC. The rectangle is a resistor. It could be any electrical device, for example, a television, a hairdryer, washing machine. The important thing is the resistor represents an electrical device. The V is the voltmeter. It has to be connected in parallel with the resistor. It will measure the potential difference of voltage across the resistor. The A in a circle is the symbol for ammeter. An ammeter is always placed in series with the device you are measuring. The ammeter measures the current in the circuit. In this experiment, we are going to increase the potential difference at the power pack. We will measure the potential difference across the resistor and the current flowing through the resistor. Our results can be collected in a table of results. So, for example, when we dialed up 1 volt on the power pack, we've got 0.5 amps flowing in the circuit. When we've dialed up 2 volts, we've got 1 amp and so forth. The rest of the results are coming up. If we then plot these results in a graph, you get a lovely straight line going through the origin or 0, 0. This means that as the potential difference increases, the current increases at the same rate. We say the current is directly proportional to the potential difference. You can only say this because the line goes through 0, 0 and it is straight. So that's what I mean by directly proportional. It's a straight line and it goes through 0, 0. The link between current and potential difference can be written as a formula. Resistance equals potential difference divided by current. If you divide the potential difference by the current, you will always get the same value for that component. This value is called the resistance. If you measure the current in amps and the potential difference in volts, then the resistance will be in ohms. This is the formula for Ohm's law. It can be represented in a triangle, and you need to learn this triangle. The international symbol for voltage or potential difference is V. The symbol for current is I. It isn't C because C is used for something else. The international symbol for resistance is R. If you use this formula in the table, you will find that each time you divide the potential difference by the current, you get the answer 2 ohms. We say the component has a resistance of 2 ohms. This does not mean all devices have the same resistance of 2 ohms, but they will have a resistance which you can find out by doing the experiment we have just illustrated. I sometimes say to students that we can visualize the potential difference as being the push behind the current, and this is a good time to use that analogy or comparison. This graph shows the same investigation on 2 different devices. One device has a very steep line and the other line has a shallower gradient. The blue line has high resistance. Notice that you have to put a big potential difference or a big push, but you still only get a small current. This is showing that it is difficult for the current to get through, so therefore the device must have a high resistance. The red line shows the opposite. I only need to apply a small potential difference or push, but the current gets large very quickly, so it must have a low resistance. This is the graph we saw earlier. This is the shape of graph you would expect for any component whose temperature stayed the same or constant. However, you probably know that when electricity goes through anything, it warms that device up. This is because electrons bang against metal ions or particles in the wires and they vibrate more, so they start to vibrate so much they get in the way of the electrons trying to get through. So in fact, this graph is much more common than the other one. It is much more realistic. This is very often shown as the graph for a filament lamp or a conductor that gets heated up. By the way, the positive and negative symbols in the graph represent the fact that you can make the current flow in different directions. For example, if you turn the wires around, put them into different terminals, or you turn around the batteries or cells to make the positive end at the other end of the battery. The shape of these graphs show that as you increase the potential difference, the current increases. But as it gets bigger and bigger, the line becomes less steep, showing that it's getting harder for the current to get through. There is more current going through, but the amount of current getting through is not increasing as fast as the potential difference is. The resistance is increasing because the metal ions are vibrating more and getting in the way of electrons. you need to know about another device called a diode. You will have seen diodes everywhere. They're the little glowing lights that you see on things like PCs, TVs, and even light bulbs. They're sometimes known as LEDs or light-emitting diodes. Most traffic lights, for example, are made of LEDs, and it seems likely that LEDs will become even more important in our life. Diodes are components that allow electricity to go in one direction only. LEDs do the same. They can only allow the electricity to go in one direction. Diodes have a very, very high resistance in one direction when you're trying to push the current in one way, but a lot less resistance when you push it the other way. In simple terms, it allows the current to flow in one direction, as shown by the graph. Right, there's been an awful lot covered in this video, and it is well worth investing time in this. But it is one of the most important and most frequently examined parts of the course. Make sure you know that the current has a symbol I. Make sure you know how to set up the circuit to measure the resistance, so voltmeter in parallel and ammeter in series with the resistor. Make sure you can sketch voltage versus current graphs for a conductor at constant temperature, or a filament lamp, or any conductor whose temperature changes. Make sure you know the following words as well: current, potential difference, resistance, ohms, metal ions, and diodes. But specifically, make sure you understand as to why the resistance increases as the current increases.